Hello, hackers. 3 of you. I guess it's officially start of class, plus Connor. Connor is reliable as always. All right, so let's wait for a tiny bit. Should have started the stream a little bit in advance so people cycle in. And we'll talk about heap and kind of state of the class now that the withdraw deadline has passed, and then go on from there. All right, so we're in week 12 and a half. Oh, the screen didn't turn on. There we go. All right, let's talk about some memes. First, some kind of memes about the class itself. I recently redid my monitor setup at home. I have like 4 monitors in a crazy configuration now. I'm still getting used to it as the meme. My room mic is not on. Test. Is that better? Test. Can you guys hear me? Awesome. All right. Yeah. So it's very interesting when you have like 10,000 pixels wide to like strain your neck to look around it. I think I'm gonna probably get rid of some of those monitors. I'm waiting for a very, very big monitor with a lot of horizontal space, but they're like, you know, not shipping because of anyways, doesn't matter. Then of course everyone likes the chickens as usual. Everyone also likes diving in to the heap challenges. Hopefully, what I've observed is maybe we finally got the point across that you need to start challenges early. People seem to be starting the heap challenges earlier, which is really great. We already have, you know, some like 14% average completion or something, which is much higher than average. So hopefully there'll be less pain on the run up to next Tuesday. This was an incredible, oh man, hold on, let me resize this meme. Why does it always, okay, that will hopefully be, all right, that'll be good enough. This is a good meme made by Anane in Discord in the fine tradition of pwn.college video memes. Okay, now the problem is there's no audio. We're not gonna get, oh, well, I guess there's audio on Twitch, but not in the real world. All right, let's restart it. It's so good though with audio. This is me dealing with a heap issue last class. And then, and then we switch to the blue screen, and then, this is great. That's a great video meme. It's good. That's great. The good old days. Probably. Oh, no one could hear it. All right. If you guys want to hear the audio, go look it up in Discord. Yeah, the days of, it's very nostalgic meme. Those good old days of Windows XP. Back then, a lot of the security problems we talk in this class were completely unmitigated, right? Right now, you still have serious issues with JIT spraying in browsers and all of this stuff that we've explored. But back then, all of the level 1 type of issues were fully and completely exploitable, right? So you take baby mam level 1 or whatever, and you use that to take over, use vulnerabilities like that to remotely take over fully patched Windows systems, which was insane. At the height of kind of the worm kind of apocalypse of like the early 2000s, sometime in late 2003, early 2004, I was in college, and I had a work study in the help desk, right, at Rensselaer Polytechnic Institute. And one time I was up super, super late because I didn't manage my sleep schedule properly I still don't manage my sleep schedule properly. Actually, I'm running on 3 hours of interrupted sleep for like the third night in a row. It's pretty bad. We had grant proposals to write. Anyways, so I might not be super, super coherent today. I apologize if that ends up being the case. But anyways, I pulled like an all-nighter playing video games or something in college. And right before going to bed, I checked Slashdot to see what the tech news were of the day. And there was some news that a new worm, and I want to say that it was, Slammer, but it was something like that. I think Slammer was earlier. And it's just a massive worm that was infecting millions of systems or hundreds of thousands of systems around the world that had just come out. And they spread like wildfire back then, because you could just connect to some system, and if it had some dumbass bug, you could exploit that bug to get full control with nothing to stop you. It was really a different world. I'm reading this article, and I realized that help desk the next day is just going to be a complete nightmare, right? Because probably everyone at RPI was getting hit by the worm, and I just noped out of work. I just emailed them, said, "Oh, sorry, I can't come tomorrow." So I feel bad to this day that there were some poor other work study kids that didn't read Slashdot early enough and came into work and got slammed with the worm outfall. Yes, I think it was Sasser, something like that. It wasn't Slammer. I think Slammer was earlier. All right, we have an important question on Twitch. What happened to the tea? Why am I drinking Starbucks? I'm drinking Starbucks because I had 3 hours of sleep. I've basically just been mainlining coffee the whole day. I used to, in graduate school, drink tea in the super, super unhealthy way. Now I drink tea in a very healthy way. I just drink tea like a normal freaking person. I used to, in graduate school, when which is really when the first time in my life where I became dependent on caffeine. In graduate school, I led our team through the participation in the Darpa Cyber Grant Challenge. And we actually, in previous iterations of this course, we talked about the Darpa Cyber Grant Challenge later in the material, where we would talk about automated vulnerability discovery. Now, we're spinning that off into a separate course. So it's a topic for a different day, but the Cyber Grant Challenge was a crazy event. Let me actually show this event, or at least show part of it. Let me show the stage. Okay, where's Chromium? There's Chromium. Okay. In like 2013 or so, DARPA decided, you know what? It's time for computers to out-hack humans. And they created that's a YouTube video. That's out of scope for this. They created an insane event live with the finals of a the final competition or whatever, being live in Las Vegas. This is right before DEF CON. This is a photo from the event, which was held in front of a giant crowd of like thousands of people. And all these people gathered to watch these machines blink lights on stage, basically, as they, hacked. They analyzed software, found bugs in it, fixed those bugs, and exploited those bugs in software run by other systems. which was super, super cool. My team, at the time I was the captain of Shellfish, that's this team right here. And I forgot why I started talking about this. Oh yeah, because of the T question. All right, I can see how today is gonna go. Anyways, because of the T question, in the run up to the Cyber Grand Challenge, the amount of work was just absolutely shockingly high, right? The amount of effort that goes into creating a functional system that can actually automatically analyze stuff, et cetera, and do it for hours without crashing. That was the real tricky thing, right? It's there were no humans allowed on stage. No one could interact with these systems in any way. There was a government certified air gap, which was guarded by armed guards. So you could not get in there to, like, press the power button if your system crashed. And the software, at least that I make, crashes quite a lot. So our team pushed themselves to complete exhaustion. It was insane. By the end, the last month I would come into the lab at UC Santa Barbara. I would work for 24 hours straight, then I would go home and sleep for 8. So that was my life of 32-hour days for about the last month. And it was just wild. So there I relied very, very heavily on caffeine and throughout the rest of my PhD. And what I started doing was I would hyper brew tea. There's this actually a technique of making drugs in, like, Russian prisons. It's called chifir. Is this hyper concentrated, basically, tea on steroids that I would just drink nonstop. Probably terrible for me. I probably have brewing stomach cancer from that, but it was pretty wild. I don't know why. Oh yeah. So, but it's much healthier if you really need a heavy boost to just drink coffee rather than drink hyper concentrated tea that eats through your stomach. So today I'm just drinking coffee nonstop. I actually panicked on my way to class because the Starbucks closest to this building closes at 4. I got there at 3:58. I was like the last person that they actually served, but it was a close thing. I would have been streaming myself sleeping if I didn't have this. Anyways, let's move on. That was what it was. All right. We'll try to stay a little more on topic going forward. Okay. So moving on with the memes. Some of you are finding some of these challenges kind of tricky. My philosophy on what I like in terms of the hacking challenges I approach is a very cool hacking playground in which there's a direction. There's a very clear goal. There's a direction that a path you can take toward that goal. In that sense, writing reversing challenges and approaching reversing challenges is very tricky, because reversing is kind of a transfer of ideas and their synthesis from one person, the author of the software, to another, the reverser of the software. Whereas exploitation is usually much more brick and mortar type, like you have the building, you just have to figure out how to disassemble it. Heap is a little different because the building is so complex. You're interacting with, as we saw in the last class, a 6,000 line heap implementation. That's just Malik.c. There's also the arena stuff that's additional lines of code, which is actually not gigantic on the scale of things, but it's much bigger than what you're used to interacting with, which are 100 or 200 line hacking challenges. And that's lines of code, of course. It doesn't always scale lines of code in difficulty, but if you have to analyze more code and understand the reason about more code, hacking challenges tend to be trickier. So it's easy to approach these challenges and get very lost. You start out triggering a Malik and a free and a scanf and a puts, and then I don't know where to go from there. It's unclear. There's a couple of strategies. One is ask in the help channels. Actually, well, I've been blown away. As I've mentioned several times, we've historically been extremely what's the term? It's a very simple word. Discouraging about collaboration. Like, I think the first several iterations of this class treated collaboration as an immediate integrity violation. Last year, we had basically collaboration hours that we would schedule right after class. And this year, we decided to embrace collaboration, and it's been awesome. So far, no one is just like dropping solution scripts in the chat, and instead people are helping each other and learning and actually doing a shockingly good job guiding people to solutions, to the point where I have a little bit of like imposter syndrome. You know, in some sense, maybe I should be in those help channels guiding you all to the solutions, but it's yeah, that there are various reasons why that doesn't always happen. Okay, anyways, on Twitch, someone says this should be the I am a god. This should be. I have no idea what I'm doing. That's pretty good. All right. So the other big news is the ascent of H-Cree. I don't know how you pronounce that. I understand it's probably just your name, but it's a good job. This is, I think, the first time in 6 weeks, or it has been 6 weeks since an ASU student took the top of the scoreboard. That's pretty cool. There right now, actually, I'll move my face on Twitch. What the hell? Sorry, OBS. Oh my God. OBS went crazy. Okay. There are only 4 people done with the heaps so far, or at least only 4 people that were also done with all the other stuff. So there's still, even the top 5 is still open, which is pretty cool to see. So, you know, don't snooze on getting into that top 5. But great job, and of course, other people in holding down those top slots that we see over and over here. Naughty Boy, Haka Roots, Trees, Judas Priest, great job. A lot of good progress already. Like I said, keep going. Don't snooze on these challenges just because people are solving them. Actually, do the opposite. Start solving them. Okay. Don't forget CTFs. Someone asked me, there's apparently a paid CTF this weekend. I've never had very good luck with paid CTFs, but if you really want to pay to do a CTF that you can probably do for free with similar caliber of challenges and so forth, you can do it. Just submit your write-ups. There's still 5% extra credit. So next, we're going to go through the impact on the grades of people of the withdrawal deadline passing. So now the people in this class are going to be in this class until the bitter end. So there's still a lot of extra credit that you can get from CTFs and other extra credit things. Okay. One of those extra credits, helpfulness. Again, I keep showing the slide. Please link your Discord ID. Pretty soon, I think Connor, as we speak, working on pulling in these extra credits because he was asking me questions about the exact formula to get from here to here. So don't snooze on that. Okay. we are at the end of the dynamic allocator misuse module. And next week, we're going to move on to race conditions. For Veterans Day, we'll likely have, instead of office hours on Veterans Day, we'll likely have an office hours like before and after. So we won't have a Thursday, but we'll have a Wednesday and Friday or something along those lines. But you'll be deep in the world of race conditions, and then we'll be moving on through the rest of the class. This is kind of that finishing sprint. And then look at your schedule between the 2nd and the 12th. Start thinking about makeup if you need that for your grade, about the makeup challenges. All right, so far, Baby Heap is off to a reasonable start, but of course, more earlier progress would always make us less nervous. But it, you know, it's off to a reasonable start. It's only been 2 days. We already have some A+, some A's, some B's, some C's, some D's. People are making their way through it, so it'll be good stuff. All right, the real thing here. This is the new grade distribution chart now that the withdrawal deadline is over. So we started the class with 155 people enrolled. After the withdrawal deadline, we had what, 85 left? We have 85 students left in the class. So many of these last week, if we back up all the way to last week's, see, toddler one's lowest 25th percentile was 0. Baby Rap's lowest 25th percentile was 0. Baby Mammoth was almost 0. And that's because, of course, as the semester progressed, more people kind of withdrew from the course but didn't file their paperwork yet or whatever. Now they have, and now all of this changes. So now the grades are kind of more reasonable among our remaining 85 students. I don't actually know what the normal withdrawal deadline is. This higher than normal, like the about average withdrawal deadline? All classes. I'm sorry. Oh, but that's an assumption. Maybe this class is actually too easy. All right. Yeah. So as people are observing on Twitch, Embryo GDB is kind of the star player of getting people's grades up. It's very good stuff. Followed by Baby Suid, and as expected, Toddler 1 remains the hardest module, but Toddler 2 is still, sorry, Toddler 2 is going to be brutal, but Baby Rob has now shifted. The students remaining in the class have done generally equally well on Baby Rob and Baby Rev, which is actually good to see, because those aren't intended to be massive. Connor's on Twitch saying, how does our drop rate compare to Navy SEAL boot camp? All right, so this is our old, I mean, this is still on the new data of just the 85 remaining students, but these are our grade distributions. So we have much higher now completion rates, your ease among the individual modules. I made a new graph, which I think is interesting. This is the distribution of progress. So it's basically the 85 progress of our 85 students sorted and then colored with a gradient per module. And you can see the modules are getting harder and harder over time, with this exception of Embryo GDB. The other thing for us that we're going to use this graph for is understanding kind of really troublesome spots. So for example, in Baby Rev, you can see this much like there's like a little color wall here, This means that there was instead of a smooth amount of people like that, you know, what we hope is almost a linear increase or a linear decrease maybe in the number of, what we really hope is everyone solves everything, of course. But what we expect to see is a linear decrease in how many people solve each successive level. These kind of big visible lines means that there's a level that a lot of people got stuck on, and the people that made it past that kept going, which is usually means that there's some sort of a difficulty ramp that we need to overcome with extra challenges to bridge the gap. Baby Shell is showing it heavily. Toddler 1 is showing it, although I don't know. We have some ideas, right, on Toddler 1, how to bridge this gap. Baby Rob's actually not too bad, but something to look into. So yeah, it's an interesting data if you're interested. All right, where does that leave us in terms of grading for the remaining 85 students? Even uncurved, our current grade distribution doesn't look too bad. It doesn't look too bad in part because I've now split out E from EU. ASU has an EU grade, which means you're failing the class, but not only are you failing the class, but you stopped working toward the class altogether. So my EU metric for this graph is that there are 3 modules other than Baby Heap, because many people still haven't even started Baby Heap, but 3 modules that have 0 solves for the student. So we have, if we take out that 5 EU, then suddenly we have a bell curve. If we separate the EU from the E, which is actually pretty nice to see. Of course, we are still running with a curve. So with our curve, now we have a really nice bell curve with 12%, what's it called? Spreads per letter. Now this is data without extra credit being added in and only prior modules. I haven't, usually when I present this in the middle of module, this graph assumes that everyone has failed the current module essentially, but this is not including Baby Heap. So yeah, we're keeping the curve as it is for now. I hadn't been changing it because it was unclear how many people we still had in the class and how well they're doing, but now we know. We'll keep the curve like that. You should be able to trivially calculate your CTF extra credit. That's how many CTFs you submitted, and then we'll soon have your meme extra credit and helpfulness extra credits calculated as well. There's a question, are we doing minuses or only base grades? We are only doing A+ and then base grades. The minuses aren't worth it. All right. So yeah, so things are, there's more D's and E's than I would like. Last year we had, I think, 6 E's and 3 D's or something like that at the end. But hopefully extra credit will make that happen and then people will keep pushing. For what it's worth, so far this is a much smaller grade curve adjustment than last year, which I think we're starting to even out between the embryo modules and extra challenges to bridge gaps. I think we're hitting a very good distribution of difficulty. Of course, that distribution should probably be done over the course of 2 semesters, but at least things are pretty good. All right, don't forget the Igrade policy. I actually emailed this out to everyone that was getting a D or an E before the withdrawal deadline to make sure they were aware of it. But if you are struggling because of illness, and that's physical or mental, or other unforeseen circumstances, you can talk to me about doing an incomplete grade. This doesn't impact your GPA until it resolves into a complete grade, which you will have until basically August 1st of next year to do all the challenges. It's curved in a different way. You'll have to do almost all the challenges, and you could potentially screw yourself by, if you have like a C and then you take this option, you're gonna have to do a lot of work to even get a C in August, but it does give you a lot of extra time. So let me know if this is something that you're interested in doing. There is a prerequisite in that you need to complete 1/3 of the challenges in every module to take advantage of that. All right. And don't forget, baby heaps due on Tuesday, and then we go on to baby race. All right. So yeah, someone on Genesis on Twitch said solve all but one module to pass. Not quite, but if you solve all but one module, assuming you know the one module is like baby heap with 30 challenges, if you ignore baby heap or toddler 2 or toddler 1, you can probably ignore toddler 2 depending on the exact number of challenges we'll end up with. You could probably ignore toddler 2 altogether and get a B with the Igrade option. If you finish everything else, including toddler 1, you could probably, if you finish everything and then only do partial toddler 1 and then ignore toddler 2, you can probably get a C, right? Anyways, so, but keep in mind, option is there. It's really the core pace of this class makes it very hard to catch up if you have a health event or something. So we're here to work with you on that. All right, don't forget, don't panic if you are on the lower on that grading scale than you would like to be. There's still makeup until 12/12 with you know, the Discord will remain up. People can help each other and so on. And a total of 5% CTF credit, 2.5% meme credit, that's 7.5%. And I'm very liberal at approving memes. And the helpfulness credit. I want to actually, I point this out every time, and probably the people that are struggling also ditch class. So maybe this is actually the wrong audience, but it's very easy, you know, with 10, a reputation of 10 thank yous on Discord, you get 4.3% extra credit with the current distribution. So that's like already over 10% extra credit that I've talked about. That's very, very within range. All right. Awesome. Raman is saying on Twitch, imagine not attending class. I guess they're on Twitch, so they are attending class. Only 3 people physically here, which is cool. You all rock. All right. So let's then move on to questions and so on. What did I just press? Oh, I see. I moved the wrong mouse. All right. Any questions on baby heap or anything else, but I guess specifically baby heap? Yes. 2.1. Let's do it. And actually, sanity check. Connor, you went over Jeff or pwn debug heap. Okay, good. Awesome. All right. 2.1. 1 sec. I need to get a caffeine. All right. Oh, and then talk about House of Force. Of course, I can talk about House of Force. All right. Let's go over 2.1 first. Where did my Chromium go? What? Why is it telling me about Charles K. Cow? Oh, that's the Google Doodle. Okay. All right. Go to Dojo. Up our challenges. Oh, wait. I need to swap my key back. I really need to synchronize the keys between these computers. Okay. Launch 2.1, and then let's take a look. All right, of course, let's first just try interacting with it. And it gives us the following capabilities: Malik, free, puts, read flag, quit. What does this mean? We can, for free, nothing happens. We do Malik, asks us for the size, 1, 2, 3, gives us an allocation, cool, and gives us the address, that's great. Call a free again, double free detected in Tcache 2. All right, so that's, you know, something. Of course, we know why that happens, because when we free that first chunk, it gets put in the Tcache bin for that size. When you free it again, Malik or DL Malik will look at, or sorry, PT Malik, that's me showing my age a little bit, we'll look at the cache key that is written into the freed allocation the first time around when it's freed. It'll see that the cache key corresponds to the correct, the address of the Tcache per thread struct, and then it'll go through the Tcache, the appropriate bin in the Tcache per thread struct to tell you that, oh shit, you've already freed this allocation. That just gave me an idea for another challenge, actually. Anyways, talk about that later. Okay, so how do we approach this? This is a testing challenge, so it's not going to give us the output of the Tcache every time. It's a bummer, but it is what it is. Let's try one thing that we haven't done, which is read flag. So it allocates the flag buffer. Okay, and then presumably reads a flag into it. Okay, now the reasonable thing for us to do would be to open this up in IDA, reverse engineer it, understand what the hell's going on, and solve it like that. And that's what I'm going to do, because I want to show you kind of the reasonable way to approach it. Of course, you can also make inferences based on level 1 or based on how the teaching one works, and then blindly solve this without reversing it. But I will do that afterwards. Connor, can you make a? Maybe we should properly handle short reads on these. If you just run the challenge, hit control. Oh. Yeah. Yeah. My concern is this can fill up our buffers, our sensitive buffers. All right, so let's open this up in IDA. All right, Oh yeah, this is the challenge. Not too bad. Hit tab, and again, as I talked about last class, Raman, we are solving two entirely. We'll just run through the whole way. IDA disassembles this or decompiles this into this crap, right? Because it's like four nested while loops, et cetera, et cetera, et cetera. That's because of how compilers will compile a switch statement that is inside a while loop. And they compile it in a way that IDA gets confused decompiling it. There are other decompilers that don't get confused. The one that I know does this well is anger management. If you really are very passionate about looking at decompilation that doesn't suck in this case. But you can kind of parse it through and figure it out by looking at these stir comps, right? So this gets called regardless every time. It'll ask you what you want to do, et cetera, et cetera. Then if what you want to do is not Malik, it'll break out of this while loop and skip this. So this is the Malik case of the switch statement. This is the free case of the switch statement. This is the puts case of the switch statement. This is the read flag case of the switch statement, etc. All right. So what do we do here? We we have two relevant primitives that are very, very relevant for reading the flag. One is to load it out of the flag file, that's read flag. The other one is puts, that prints data to us, right? So we already have one primitive that reads the flag file and another primitive that writes data from memory to standard output, right? So those are the two primitives that, of course, we'll want to chain together somehow to leak out the flag. What's the problem with doing this? Well, the problem is that this is the flag buffer. I don't know why IDA thinks it's size 4, but this is our flag buffer. And if you look at where the flag buffer is used, it's used in 3 places. One is where it's allocated. One is where its size is read out. And then the third time when it is used as the target of the buffer for this read. Puts, on the other hand, uses a different pointer. And that the pointer puts uses is the one that free and Malik use as well. Okay, so we have 2 different pointers. If we do a read flag, it'll allocate a pointer. Then it'll tell us to, then when we, sorry, it'll allocate a pointer. It'll allocate a buffer. It'll make an allocation using Malik of some size, and this allocation is not hard-coded in size. In level 1, which we did on Tuesday, it was hard-coded in size. In level 2, it is not. Right? So how do we figure out the size? Oh, let's see how it's determined, right? So this is our flag buffer size. Now, why is knowing the size important? Of course, it's because of the dangling pointer in this challenge. That's exactly the same as the dangling pointer in level 1. In level 1, we solved it, and let me refresh that. Oh, that was on my desktop at home. Let's download level 1 real quick. All right, baby heap level 1 gives us the same primitives: Malik, free, puts, read flag. Let me zoom in. Everyone can see that better. All right, and we solve this by allocating a, well, first let's just object dump this to see what the size is going to be. because I just don't want to open another IDA and oh my God, sorry about making you look at AT&T syntax. That was bad. Okay, let's see. Here we Malik. It'll be the second call to Malik in this function. I should have opened this in item. Then RDI is RAX. RAX is RBP minus A0. Can you imagine that we used to use objdump as the reference reversing tool for the class? Okay, that's not good. Okay, minus A0. Look at what's A0. Okay, we write RAX into that. Okay, this is let's just open it up in IDA. I am way too sleep deprived to look at GDB. Sorry, not GDB. I'm never too sleep deprived to look at GDB. Too sleep deprived to look at objdump. All right. So this is level 1. You're just super lazy and just hit tab. Here's the size that we want to allocate. This is the size that gets allocated for the flag buffer. It's 749, which now I remember from Tuesday. I remember that number. But anyways, this is the equivalent code for level 1.1. And this is the code for level 2.1. If we go back and forth, we see very few. Let me just do this. Boom, very few changes, right? Just in terms of spotting. They both do this, ask for the size, do A2I Malik, blah, blah, blah. The free case is the same. The puts case is the same. The read flag case is the same, almost, with one exception. Level 1, it does a Malik of 749 bytes. Level 2, it does a Malik of this flag buffer size. Why is it important, that distinction? Because if we know the buffer, of course, the way that we do this, because free doesn't actually invalidate pointers, it just frees the allocation. And in this program, that pointer is not explicitly nulled out or anything, so we can use it afterwards. We just exploit what's called this dangling pointer. We say allocate a 749 byte buffer. Awesome. We free it. When we read flag, it'll allocate a 749 byte buffer, which will cause it to pull our old buffer out of the T cache and use it to write the flag into. And then we can just puts, and here's our flag. All right. So what's preventing us from doing this in level 2? Well, one thing that's preventing us from doing this in level 2 is that we don't know the size of that buffer. So we can't say, okay, it's 749 bytes, blah, blah, because we don't know what it is. So, and presumably level, if you do read flag, what we do know is the address of the flag buffer. So this is level 2.1. And when we allocate it, it says, okay, I allocated the flag buffer to this address. Of course, nothing stops us from doing that again. If we do read flag again, it'll allocate a new buffer. Little Malik, get a new buffer, and it tells us the new address. And of course, no other Maliks happen between those us triggering read flag once and the second time, right? Because we understand that program, it doesn't do Malik other than when we tell it. And so we can figure out the size. We can take this number and subtract that number from it. Many ways to do this, Python, GDB, etc. We can just do, or even bash. probably the worst way to do it, but boom. We don't want it in hex, we want it in decimal. Oops. 736. So you might say, okay, the distance between those buffers is 736. So if I allocate a 736 size buffer, free it, all is good, right? Well, let's give that a try. I shouldn't have killed that function. Let's make sure that if we read flag and reflag again, is the same. Yep, same offsets into the heap. So then we say, okay, well, let's Malik 736 read flag, or sorry, free. Now we have that dangling pointer, read flag. Hopefully it gets our freed allocation from the T cache, and we put nothing. Well, why? We forgot something, one thing that's very important. We miscalculated that forgetting that important thing forced us to, or caused us to miscalculate the size of the buffer that we want to malloc. What's the thing we forgot? We forgot the metadata, as I think Raman just said. Yep, Raman just said on Twitch. We forgot the metadata. So our two chunks, the first read flag chunk and the second read flag chunk, they're right up against each other. But the buffer itself, the size that's relevant for malloc, the two buffers aren't up against each other. You have the first chunk's metadata, then the first chunk's actual usable allocation space, then the second chunk's metadata, which is 16 bytes, and then the second chunk's actual allocation space. So there's a little bit of padding here. What it means is, what we really want to do is malloc 720, that is the usable space minus, or the size of that chunk minus the metadata, because that's what you pass to malloc, and it tacks on the metadata, right? So what we observed, that difference was including the metadata. What we want to allocate is without including the metadata. Then we free it, then we read flag, then we puts. Boom. So what's that core thing? The core thing is keeping in mind the metadata when we're figuring out those offsets. Let's take a quick look in IDA to see if we could have just reversed where this is even coming from. The flag buffer size is random, but it looks like we didn't seed the random number generator on level 2. Yeah, it's a constructor. srand is not linked in. Oh, no, yeah. No, flag seed is linked in. Hold on. But both times I've run it. Oh, shit. You're right. Okay. I had a major brain fart just now. All right. So the flag buffer size, just for completeness, so we understand how these challenges work, the flag buffer size is randomly set. We call rand, which returns a random floating point between 0 and 1. We modulo it by 872 and we plus 128. That's just some random number between 128 and 872 plus 128. So the and how is this random number generator seeded? Well, you've seen this in other challenges at this point, and Connor's probably walked through this, but this function is a constructor. It gets launched by or it is included in the array of initializers, which all of them get called when the program launches before main runs. And what it does is it reads out it reads the flag, and it uses the flag to seed the random number generator. So this identical challenge for everyone will be different and at runtime behavior in terms of, for example, this allocation size. Or you've seen it in Baby Rev to randomize Yan 85, stuff like that. Okay, Raman has a question. Why does allocating a large value like 1337 work for getting the flag? This is a brilliant thing that actually is an unintended bug in this challenge. So let's restart this. Let's malloc something large. That might be too large. No, it's not. We free it. We read flag, and we already see that we're gonna win. We put and we get a flag. All right. Why would this work for getting the flag? Well, this works for getting the flag because let me pull up the relevant lecture and we'll go through that real quick. Now I'm vaguely terrified that this unintended bug actually, okay. Yes, so never mind, we did cover it. libc has different caches for different sizes. Tcache is just one cache for malloc in libc, in ptmalloc specifically in libc. So we have our 64 Tcache bins, size 16 to 1034, 1032. We have our 10 fast bins, which are mostly irrelevant nowadays because Tcache kind of overloads them unless you exhaust your Tcache, then fast bins come into play. You have, and then otherwise, if you free a chunk that doesn't fit into the Tcache, that's why 1337 is one number, or the large number I put in is another, and doesn't fit into the fast bin, and any chunk that doesn't fit into Tcache likely also won't fit into the fast bin unless the Tcache is full for other reasons, will get inserted into the unsorted bin. And what happens when you malloc, and this we can actually look up the malloc source code to confirm. Oh no. One sec, let me enable dev sources. That should be enough. Okay, we're going to look at the malloc source code as soon as it's all downloaded. But the basic idea, while we wait, is that the way malloc works, if you malloc something less than 1032 bytes, it's going to look at the Tcache. If you malloc something, if there's nothing in the Tcache and the allocation size is less than 160 bytes, it'll look in fast bins. Otherwise, it'll go through the unsorted bin and sort the allocations that have been put into the unsorted bin. That 1337 was put in the unsorted bin, and it is an allocation that is sufficiently large to satisfy the 749 or whatever that value is for you, right? Because that value is always, we specifically make it so that it fits into Tcache. So malloc will pull that value out of the unsorted bin, or pull that allocation out of the unsorted bin, split off the chunk you need, and use that. Which actually is probably we should fix that, Connor. That unintended solve doesn't probably. it'd be good to fix or explore in a separate challenge. Cool. So basically, that's why if you provide a larger number than Tcache supports, you can get the flag that way as well. Okay. Another question. So Raman really played around with the heap, which is great. Raman observed that when they allocate a really large number, right, something like this, that might be, well, let's see. Malik. We get something that looks like a libc address, right? What the hell? Where's our normal, let's just try this, Malik. 1, 2, 3, that's a stack address. We can recognize that at this point. This is, looks like a libc address, 7F stuff, right? Let's see what it is. Here's the challenge. It is 7F C9 EEF 08010 right here. It is mapped right before libc. It is a readable, writable mapping, not backed by any file. But what is it? Well, when Malik receives a request that is just absurdly large, it's not going to bother keeping that in the heap area. Why? Because this can be bad for fragmentation. If you allocate something gigantic, you want to be able, and then deallocate it, you want to be able to release that memory. Because otherwise, if that memory stays around, you can eat up all of your RAM, even though in terms of allocated buffers, you're not using a lot. Fragmentation is a serious concern of heap implementations. And if you allocate a giant buffer, a giant allocation onto the heap, then you malloc something small after it and free that giant allocation, you're stuck with all of that memory allocated that you can't free. So the solution for this is memory mapping very large allocations. If you get a sufficiently large allocation to malloc, it'll mmap it. Now, why is this relevant to this class? It's relevant to the class because even with ASLR enabled, when you memory map something and allow the kernel to choose a random address for you, it's going to stick it right up against the libraries. The next memory map is going to go right up against that as well, and it'll just keep walking backwards in memory. That means that no matter how many times I run this program, the relative distance from my buffer and libc and libld will stay the same, which means that if there's a relative arbitrary write that I can do due to a bug in the program, I can now impact deterministically libc data structures, which is real bad news. That's why the libc behavior is relevant, and the libc behavior happens because of libc's kind of best effort attempts to keep fragmentation in check. Now, what happens if I malloc this again? Hold on. Okay, that size it maps it. So if you look, before this mapping ended at 252A00, now it is still there. Where did it get mapped? 88 EE. Oh, it put it elsewhere. Okay, we have to find what's the difference between the before and the after. All right, somewhere one of these numbers is different with one of these mappings has been extended. Now there are certain sizes. libc or PT Malik has a lot of different configurations. If you do a man Malik, it'll tell you a lot of, yes, here it is. How do you control how big an allocation has to be before memory map is used? Well, you can set this environment variable. And if you set this environment variable to 1, for example, let's do it. Malik will just always I think you have to be bigger than the T-dash still. No. Is it Malik mmap threshold? Let's. Wow, my computer's really overloaded. Yes, Malik mmap threshold underscore. Okay. So the map at the man page lied. If you set this, Malik 1, 2, 3, boom! It memory maps an entire page for us to use the little tiny bit of it, 123 bytes. But in certain scenarios, this is what you want, because when you then free it, it's going to get unmapped. So let's take a quick look. Nice, 1, 2, 3, 7, 8. That's a good fit. That's a good fit. Okay, anyway, so we memory mapped in 7F5 CC44 CC44 EA CC44 EA. So it stuck it here in between libc and libld. So something had probably been mapped there, got unmapped, and now that's where the kernel stuck it. Again, it's not libc figuring out where it wants it memory mapped. Is the kernel putting it into the kind of general space that it chose from memory maps. If we do this again, actually if we free it and cat, so again it was here, EEA, boom, it's gone. So Raman is asking, that address plus hex 1000 would give you not the base address of libc, but the base address of libld, the dynamic loader, which actually, I don't know about nowadays, actually. Can I make this statement? So there was a brief period of time where libc was heavily secured. I mean, libc, that it's a constant, not just in the heap, in other places in libc, it's a constant trade-off between security, performance, et cetera, et cetera. And there are now parts of libc where data such as file objects and stuff are kind of pseudo-encrypted to avoid easy control by attackers. There was a period of time where libc was getting hardened, but no one was thinking about libld. And so a relative write into libld was actually more useful in many cases from a security perspective. But yeah, this basically allows us to get it. But when you free this, which we just did here, it actually deallocates the memory, which is a great, it would be a semi-reasonable way to, well, no, it doesn't, it's not a good way to fight any security problem, but it's an interesting difference in behavior. Malik, by the way, has a lot of other environment variables that impact its behavior. And you can look at this by going to the project How to Heap. It's a repository created by Shellfish, maintained by Shellfish. Now it's actually primarily maintained by one of our graduate students here at ASU, of a lot of different heap exploitation. Sorry, I'm starting to really fade. Heap exploitation techniques on different versions of libc in this very cool way that it's presented. So if you look at a very simple technique, which you actually do later in this challenge, which is House of Spirit in this module, it actually demonstrates in C code how House of Spirit works. It creates a fake chunk, et cetera, et cetera. Anyways, if you look here, it has a lot of other, aside from having tons and tons and tons and tons of different libc attacks, it has some other things for you to look at there, including hardening. So there's very interesting other, we just explored the Malik mmap threshold environment variable. There's also Malik check, which enables additional security checks. So if you are very passionate about the security of your applications and you don't care as much about the performance of dynamic allocation, you can enable that. It's still not perfect. Any checks typically can be bypassed because, again, the attacker, depending on the vulnerability in question, potentially has full control of that metadata. That's a very, very hard position to be in as a defender. And Malik perturb is very interesting. Malik perturb will overwrite data, clean it out, make sure that use after freeze aren't immediately harmful. Overlapping allocations are still harmful for other reasons, but it would at least, this Malik perturb would make our levels, level 1 and 2 at least, unsolvable. Let's take a look. Here's the normal solution, of course. Malik, free, oops, no. Malik 749, free read flag puts, boom. Let's set Malik perturb. No, in this case, it would still be a problem. Never mind. It won't help us. So case in point, for no mitigation is perfect. Malik 749. Free read flag puts. So we get the data. We also get a bunch of random trash. That is the perturbed, overridden data that probably it's OXFFFF if I had to guess. Actually, let's hard copy. FFFD or FD. That's what it overwrites all the allocations with. Why did we still get the output even though Malik cleared away the actual data? Well, we still get it, of course, because that is an actual live allocation that we can access due to a use after free. Right? So it's there are some levels where you would not be able to, that you wouldn't be able to solve if you enabled this Malik perturb option, but it's very rare that software is run with non-standard security options. So this Malik perturb is really a footnote of heap exploitation guides. You don't really have to often worry about it in real life. All right. Oh, is the class over? All right. So that's the time we have today. Thank you for joining us. Let's see. Would it be more useful? You don't have to answer now, but if people can discuss and get a consensus going on Discord to have ops hours tomorrow or Monday, then I'll hold an ops hours either tomorrow or Monday as appropriate. Maybe Monday early afternoon would be better. You have 24 hours for final questions, but think about it. Strong opinions. I'm open to hearing feedback. Otherwise, Twitch seems to overwhelmingly say tomorrow. You can do Monday. I'll do tomorrow. Yeah. All right. So we'll do both. Why not? So I'll hold an office hours tomorrow. Hopefully, I'll be relatively caught up on sleep, but we'll see. Baby Jan doesn't always allow that. But otherwise, we will see you all. Oh, yes. Tomorrow, let's see. How about 3:30? Tomorrow at 3:30. If that somehow doesn't work, I think that should work. But if it doesn't, I'll announce ASAP on Discord. Cool. All right. See you later. Good luck. Break those heaps.